Dear students, this video will discuss the difference between a software failure and a software anomaly. A failure is defined as the inability to perform a required function or meet specified requirements. Identifying a failure often requires an oracle, a method or tool that determines whether the outcome is correct or a failure. For example, a system crash or inability to process a payment constitutes a failure. An anomaly, on the other hand, is a deviation from normal behavior. It represents a data point that lies beyond a predefined threshold of normal data, such as an unusual spike in CPU usage or network activity. However, anomalies are not always failures. For instance, a person being 2 meters tall is statistically anomalous but not a failure. Similarly, high webshop CPU usage during Black Friday sales is an anomaly but an expected behavior under those circumstances. Conversely, failures are not always anomalies. A failure that occurs frequently, such as trains being delayed during snowy weather in Finland, may no longer be considered anomalous because it is a known pattern. Here, we explore the distinction between anomalies and failures and its relevance in log analysis. Typically, the goal of log analysis is to detect failures or identify their causes. Detecting anomalies can be helpful in this process, but they are not the ultimate goal. Unsupervised anomaly detection is designed to identify rare or unusual events in data. They operate without labels and cannot distinguish failures from anomalies. They simply flag deviations from a pattern. For example, an unusual log messages might be flagged as anomalous without identifying if it leads to a system failure. Supervised machine learning models, in contrast, are trained with labeled data, allowing them to identify failures. They rely on examples of known failures during training to recognize similar issues in future data. This approach requires labeled datasets, which are often scarce or incomplete in practice. Humans without domain knowledge about the software system under investigation can recognize anomalies by comparing logs and spotting differences. Humans might also identify failures using their general-purpose knowledge, such as interpreting a message like fatal error when reading on device X as indicative of a failure. Humans with domain knowledge bring additional expertise to the table. They can assess which failures are more serious based on domain understanding. For instance, while 2 logs might show fatal errors on different devices, domain experts might know that an error on device Y is more critical due to its role in the system.